What's up, young mathematicians? Today we're going to talk about solving systems of linear equations algebraically, and we are going to use the elimination method. Elimination is a good method to use if neither of the equations in your system has a variable that is isolated or easily isolated. Sometimes, even though a variable could be isolated pretty easily, elimination might be a better method to use. Now, that's a matter of opinion, but I'll let you see for yourselves after you work a few elimination problems. In the elimination method, we want our x's and y's to be lined up in our two equations. They'll be on the left. The constant will be on the right. Once you get them lined up, you're going to check to see if one of the variables has opposite coefficients. If they do, that makes the problem go a lot quicker. If they don't, you'll have to multiply one or both of the equations to make opposite coefficients. If you're on to step 3, you'll add the equations together to eliminate one of the variables. Step 4, you will solve for whatever variable is remaining. 5, you'll substitute the answer you got from 4 into either of the original equations. Solve for the other variable. And 6, write your solution. So let's get to it. Example 1. So our x's are lined up. X is above x. Y is above y. And what we're looking for are, do our x terms have opposite coefficients? This has a coefficient of 1. This has a coefficient of 3, so no. But let's look at our y terms. In the top equation, we have a positive 2. In the bottom equation, we have a negative 2 for our coefficients. So that's what we want to work off of. And when we have this situation, you are going to just add your two equations together, because adding 2y to negative 2y gives you 0. So let's work from left to right, though. What is x plus 3x? That's 4x. Now, 2y plus negative 2y, 0. The y terms are eliminated, hence the name elimination method. We need to add the constants as well. Negative 2 plus negative 22 is negative 24. We will solve what we have left, so we'll divide both sides by 4, and x equals negative 6. So there is half of our answer. We can plug that negative 6 into either of the original equations. I'm probably going to plug it into the top one because the coefficients are smaller. All right, so in the top equation I have negative 6 instead of x, so negative 6 plus 2y equals negative 2. I'll add 6 to both sides. 2y equals 4. Divide by 2, and y equals 4. So our solution to this first system of equations is negative 6, 4. All right, there's a second example. If you would like to pause the video, it'll take a couple minutes to work that one out. Okay, we're back. All right, x's and y's are lined up. We notice right off the bat the x's have opposite coefficients, so we're just going to add the two rows together. X plus negative x, eliminated. 9y plus negative 6y, 3y. Negative 4 plus 1, negative 3. Divide both sides by 3. Y equals negative 1. So there's half of our answer. Let's plug that negative 1 into let's go with the top equation. We're solving for x, and x is positive, so I'm going to go with that one. So we have x plus 9 times the y value that we just got, negative 1, equals negative 4. So x, positive 9 times negative 1 is negative, or minus 9 equals negative 4. Add 9, x equals 5. So our solution to this second system of equations is 5, negative 1. Okay. Example 3. Our x's are lined up, our y's are lined up, constants on the right. This time, We look at the x coefficients. We have a -2, -1, so those aren't opposite, same number, opposite sign. Look at our y's. We have a 2y and a 2y, so we have the same number but not opposite. So what we're going to do is make them opposite. Now, you can just subtract these two equations, but often we teach this by multiplying one of the rows by -1 so that you can end up adding the two equations together. There's just a lot more room for error when we subtract, especially when we have some negatives involved. So what we're going to do is multiply either row by -1. I'll just go with the top row. So we're going to put parentheses around that whole top row. And we're going to put a -1 out in front of those parentheses, meaning we are going to multiply that entire row by -1. So the top row changes to -1 times -2x, 2x. -1 times 2y, -2y. -1 times -20, 20. So there's the new top row. I'll just rewrite the bottom row right below it. -2x plus 2y equals -15. So we created the opposite coefficients here. So now we are ready to just add those two rows together. So what is 2x plus -x? That is x. What is -2y plus the 2y? Those are eliminated. And what is 20 plus -15? That is 5. So x equals 5. There's half our answer. And let's plug that one into the bottom this time. So I have negative and then my x that we just got in the first step. 5 plus 2y equals -15. So we'll add 5, add 5. 2y equals -15 plus 5, -10. Divide each side by 2, and y equals -5. So the solution to this system of equations is 5, -5. All right, pause the video for a second if you would like, and work out example 4. Okay, we're back. So we see we have 5 for the coefficient of the x terms. We want one of them to be negative. So we are going to multiply the whole entire row by -1. Now what does that do to every term in the row? It just changes it to its opposite sign. So let's save a little time and just go ahead and kind of make note of that. So this would be -5x. This would be +7y. This would be -21. All right, we're ready to add the two rows together. What is -5x plus 5x? Eliminated. What is 7y plus -7y? Eliminated. So this whole left side was eliminated. Now mathematically there's something left over there, and that is 0. What do we get on the right side? -21 plus 29, which is 8. So this should look familiar to some stuff we've seen before. When the variables drop out and you're left with a mathematical statement that is not true, 0 does not equal 8, your answer is no solution. All right, let's move on. So example 5, 5x minus 9y equals 6, and -x plus 6y equals 3. The x's, y's, and constants are lined up, so we're good to go there. Now we look at our coefficients, and this time we don't have the same number, opposite sign, or just the same number at all like we did on the previous two examples. So what we're going to have to do now is multiply one of the rows by a constant that will turn either the x coefficient or the y coefficient into the opposite of the x or y coefficient from the other equation. So can I turn a 1 into a 5? Yes, that's the easiest route to go here. I couldn't turn 6 into 9 through multiplication without using a fraction, and we don't really want to do that if we can avoid that. So we're going to multiply this entire bottom row by 5. So the top row stays as is, 5x minus 9y equals 6. And now the bottom row, when we distribute, becomes -5x, 5 times 6y, 30y, 5 times 3, 15. All right, so now that we've created these opposite coefficients here, 5 and -5, we are ready to add these two equations together and do some eliminating. All right, so what is 5x plus -5x? Well, those terms are eliminated. That's 0. What is -9y plus 30y? That's 21y. What is 6 plus 15? 21. Divide both sides by 21. Y equals 1. And let's plug that into, let's go with the bottom equation. Again, it doesn't matter, it's your choice, but I'm going to go with the bottom. -x plus 6 times 1 equals 3. -x plus 6 equals 3, minus 6 minus 6. -x equals -3. But we don't want -x, we want x. We have to divide both sides by -1. X equals 3. All right. So the solution to this system of equations is 3, 1. All right. Pause the video for a second and work out example 6 if you want some practice. All right, we're back. Let's do it. So looking at the x coefficients, would it be easy to turn 4 into 6? No, but it would be pretty easy to turn a 5 into a 15. So we're going to multiply our bottom row by 3. The signs were already opposite, so I don't need to include a negative there. So the top row stays as is. 4x plus 15y equals 17. And here we get -18x, -15y, and 60 and 21, 81. All right, so we're ready to add the two rows together. What is 4x plus -18x? That's -14x. 15y plus -15y, those are eliminated. 17 plus 81 is 98. All right, let's divide both sides by -14. -14, and x equals 7. We need to plug that x into either one of our equations, and I'm going to go with the bottom. So I have -6 times 7 minus 5y equals 27. So that would be -42 minus 5y equals 27. I'll add 42 to both sides, add 42. And -5y equals 69. And something doesn't look right there. So let's see if I can track down a mistake here very quickly. Seven and 42, so we add 42 to 27. Okay, I see the mistake here. 98 divided by -14 should have been -7. So let's fix that. Let's erase here. Okay, so we'll plug into the bottom again. But we'll plug it in with the right sign. So we have -6 times -7 minus 5y equals 27. So -6 times -7, that is 42. minus 5y equals 27. Now we'll subtract 42 from both sides instead of adding it like we did a second ago. Negative 5y equals negative 15. Both sides by negative 5, and y equals 3. So the solution to this system of equations is negative 7, comma 3. Let's just write that out here. Negative 7, 3. All right, moving on to example 7. So example 7, our x's are lined up, our y's are lined up, the constants are lined up. So coefficients, though, are different. Could I easily turn a 7 into a 10? No. Could I easily turn a 2 into a 9? No. So in this situation, we have to multiply both rows by a number to create the same or opposite coefficients, rather. And so we have a lot of options here. I mean, you always want to use the smallest numbers possible. I could multiply the top row by negative 7 to create negative 70 here, and the bottom row by 10 to create 70 here. Or we could eliminate the y's. I think I'm going to go with the y's just because the numbers are a little bit smaller. So I'm going to turn both of these numbers, 2 and 9, into 18. So we need to multiply this top row by 9. And since this 9 is negative, I won't have to worry about the signs. I mean, I am worried about the signs, but they're opposite already. But both of my numbers I multiply by here are going to be positive. So what do we get here? 9 times 10, that's 90. X, 9 times 2y, 18y. And 9 times 14, that would be 90 plus 36, 126. And on the bottom, we have 2 times 7x, 14x. 2 times negative 9y, negative 18y. And this is why we chose the numbers 9 and 2 to create this situation right here. 2 times negative 11 is negative 22. We are ready to add those two rows together. So 90x plus 14x is 104x. 18y plus negative 18y eliminated. 126 plus negative 122, 104. So we divide both sides by 104. 104. And x equals 1. I'm going to plug that into the top row. So I have 10 times 1 plus 2y equals 14. Well, 10 times 1 is 10, so I'm going to subtract 10 on both sides. 2y equals 14 minus 10, 4. Divide by 2, divide by 2, y equals 2. So the solution to this system of equations is 1, 2. 1, comma 2. Okay, pause for a moment and work out example 8 if you would like some practice. Okay, here we go. Do we want to turn the x coefficients into 14? Or do we want to turn the y coefficients into 20? I think I'm going to go with the x's since the signs are already opposite. Let's go with the y's just to do something different this time. So I want to make them both 20. One of them needs to be negative. So I'm going to multiply the top row by 4, and let's make it negative 4. Bottom row by 5. So what is our new top row? Negative 4 times negative 2x is 8x. Negative 4 times 5y is negative 20y. Negative 4 times 17 is negative. That will be a 40 and a 28. 68. Bottom row, 5 times 7x, 35x. 5 times 4y, 20y. So here's the reason we chose the numbers that we did. 5 times 5, 25. All right, now we're ready to add the two rows together. What is 8x plus 35x? That is 43x. Negative 20y plus 20y eliminated. Negative 68 plus 25, negative 43. So we're going to divide both sides by 43. and x equals -1. All right, let's plug that into, I'm going to go with the top. So we have -2 times -1 plus 5y equals 17. I know -2 times -1 is +2, so I'm going to subtract 2 from both sides. 5y equals 15. 5 by 5, 5 by 5, y equals 3. So the solution to this system is -1, 3. -1, 3. All right, examples 9 and 10. Now, in this case, we finally have one where the x's and y's are not lined up. So we have a little bit of work to do in the first step to get the equation where we want it. Now, in the first equation, the x and y are both on the left side, but they're in a different order than we're used to seeing. So we're just going to flip-flop those. So we would write it as -6x plus 5y equals 9. All right, so let's look at the bottom equation. 8x is where I want it. Now the y term is on the other side, so we need to move it over to the left. But if you move a positive 9y over to the left, it becomes a negative 9y. We want the constant on the right, so this 5 on the left would become -5 on the right. So there is our system of equations. So let's turn the x's into 24s. Again, there's other ways you could do it. You could turn them into 48, and you'd just be dealing with larger numbers throughout the problem. But the least common multiple of 8 and 6 is 24. So I'm going to multiply the top row by 4. That would give me -24. I'm going to multiply the bottom row by 3. That would give me positive 24x here. So our new system is -24x. 4 times 5y is plus 20y. 4 times 9 is 36. 3 times 8, 24x. 3 times -9, -27y. And 3 times -5, -15. So when we add, these are eliminated. Here we get -7y. Here we get 21. Divide both sides by -7. Y equals -3. So we're going to plug that back into, let's go with, you can use the originals, you can use the ones you changed up. I'll just go with this first original here. So we'll go 8x plus 5 equals 9 times -3. 8x plus 5 equals -27. Subtract 5, subtract 5. 8x equals -32. Both sides by 8. X equals -4. So the solution to this system is -4, -3. Squeeze that right in here. -4, -3. Okay, pause the video for a minute and work out example 10 if you would like some practice. All right, we're back. So on example 10, on the first equation, x is where we want it. Y is on the right side. We want it on the left, so I'm going to move it over there. It will become -30y. And the constant is on the right. That's where we will leave it. Now this one, both the x and y terms are together, but they're on the right side of the equation, so we want to move them over to the left. So -3x on this side would be 3x. 3y on this side would be -3y. And then the +3, the constant over on the right, would become -3. All right, so looks like we can turn the 3 into a 21 or the 3 into a 30. I think I will turn the 3 into a 30 just because multiplying by 10 is very easy. Really, multiplying by 7 here wouldn't be much more difficult, but it's okay. I'm going to change the bottom row, multiply by negative 10 because I need to make this positive 30. So top row stays the same. It is 21x minus 30y equals negative 39. The bottom row becomes negative 30x plus 30y equals 30. So when we add, here we get negative 9x. The y terms are eliminated. Here we get negative 9. And you can see that x is going to equal 1. X equals 1. And I'm going to go ahead and plug that into my changed up bottom equation here. So 3 times 1 minus 3y equals negative 3. So subtract 3 from both sides. Negative 3y equals negative 6. I'm a negative 3. Y equals 2. So the solution to this system of equations is 1, 2. Excuse me. So that's it for the systems by elimination, but I did want to show you one thing. So look at this system. It's a multiple choice situation. I just want to remind you, yes, we've learned to solve by graphing, we've learned to solve by substitution, now we've learned elimination. But don't forget, in a multiple choice situation, you can take the answers you're given and plug them in to see what works if you're not sure of what method you want to use. So don't forget that method, to plug your answers in and see what works. So we could go, okay, negative 10 times negative 7 minus 3 times negative 10. That's supposed to equal negative 18. So let's see, that's 70. That's plus 30. Does that equal negative 18? No. So it's not A. Let's check B. Negative 10 times negative 4 minus 3 times 3 is supposed to equal negative 18. So let's see, that would be 40 minus 9, which is 31, does not equal negative 18. So B is out. Let's check C. Negative 10 times 3 minus 3 times negative 4 is supposed to equal negative 18. So that'll be negative 30 plus 12 equals negative 18. Yes, that is true. It's supposed to be a 12. So we just need to check it in the bottom equation and see if it works. So we have negative 7 times 3 minus 8 times negative 4, and that's supposed to equal 11. So what do we have here? Negative 21 and plus 32 equals 11. Yes, 11 equals 11. So choice C works in both equations. So C is the solution there. So just want to make sure you knew plug-in answers you were given in and checking is also a valid method for solving a system on a multiple choice test. All right.